Hello, everybody. We're gonna do lab number 3. As we open SIMULINK, in this place, we're gonna open library and we're gonna start on basic. So we're gonna go in first of all into subsystems or port and subsystem, and we're gonna extract subsystems. Then we're gonna go into lookup tables and we're gonna extract direct look tables. Um, and we're gonna now we're gonna have a multiplexer. We're gonna go to you could put multiplexer or um, mux, and you would produce right here. The mux is 2 to 1. Then we're gonna have a sim out, and this is what it does. Or we can go to sinks, and you can see sim out right here, or to workplace. What it does is to provide the output. Then we're gonna have input or a constant. And in this moment, we're just gonna change this one to the name input BP. Right click it and make sure that the constant value is 120. So now we're gonna go to into here and we're gonna make sure the output. We're gonna make sure that we change it instead of sim out. We're just gonna put out R. Make sure that we have it as an array in 2D. It's no longer fixated point data, and this is -1, and we're good. Um, Now we're gonna go into the subsystem part 1. So this subsystem um, is our first subsystem that we're gonna be working, and we're gonna name it index selector. We're gonna go inside here to see the the menu. As you can see, we can navigate it here. We're gonna exit one more time and just gonna see the parameters, log parameters, and just make sure that we have it right. We're gonna have front port icon, read write, alt. So this is accurate. And then we're just gonna go inside here. Once we go inside here, we're gonna have to create a new one, a new system, and then we're gonna put pulse generator adder. And then we're gonna select this one. Now we're gonna go into three third subsystem. Or subsystem. Once again, we're gonna use subsystem to create our own subsystem. This one is made by us, and then the output we're gonna have it as. So we're gonna eliminate this one and the input, and then we're gonna have the connection. As we're just gonna make sure that it has the name into it. This one will be your be good subsystem. And then it will be output or out one. As I mentioned, it's just one. Um, this is just for reference. Then we're gonna go into the pulse generator in the parameters, log parameters, and then we get just gonna make sure that the amplitude is 1, the period is 1, the period is 10, the pulse width is 5, and then the phase delay is 0. Time base, so this is accurate. So we just want to make sure that this is center. Now we're gonna go inside into the parameters of this subsystem. So this one, read right, is accurate. We just is accurate. Then the port number, the output port number is 1, and that's accurate. Now we're just gonna go inside here and we're gonna make a new subsystem. In this subsystem, we're gonna have a constant, an addition, or sum. Granted, this is different, a little bit different. We're gonna utilize this kind of summation. Now we're gonna use a memory. Then the output. All right, so we got it here. We're gonna have the input or the constant, and we're gonna call it IC. Then we're gonna have it to the one of the addition. Then the memory, we're gonna connect it. And this one we're just gonna connect the output to the input of the memory as a feedback. Now we're gonna once again break this one, and we're gonna have the output connect to this one. And now the output is gonna be output 1. As one more time, we're just gonna center it, and that's what we have. The important thing right here is to have for constant, just to check the parameters. This is accurate. The summation, it will be rectangular, plus plus is accurate. Then the memory, it will be 0. And we're gonna click right here, inherent sample time. And then the output, we're just gonna make sure the is number 1. And yes, that's what we have. Now we're gonna exit. As we can see, this connection disappear. So we're just gonna connect it this way. Now we have this connection and we're gonna exit. So we're gonna center it and exit. And now we're gonna go to into the parameters of this one. Direct look. So we're gonna select the number of dimension is one, and then we're gonna select the data. It's gonna be 200 to by 80 element apply. Now we're gonna create a new subsystem. So this subsystem, we can connect this to this. Just gonna move the multitensor. Now we're gonna get another subsystem. Now we're gonna double click. We're gonna eliminate these just for reference, but we're gonna need to have this is the longest part. So this is very time consuming, but we're gonna try to do it as much as we can. We're gonna go into we're gonna need the for this transformer we're gonna need two inputs or inputs. I'm gonna select one, copy and paste the second one. Now we're gonna select three constants. Paste three. So now we're gonna start selecting or putting names to the information to make our life easier. So this port is gonna be number 2, and we're gonna call it BP. And this port is port number 1, and we're gonna call it CL. Now this one is gonna be N. This one is gonna be CLW. Okay, so N, we're gonna double click and we're gonna have the value of 0.5 in sample time infinity. The CW, oh, sorry, this one is CI. This is I, and we're gonna go inside here, and we're gonna put the value as 5 plus 5 I. Then now this one, we're gonna change it to 1500 plus 500 I. And we're gonna change the name to CI. I'm just gonna make it bigger just to visualization. Now we're gonna input 3 absolute values. So the 4 different values, absolute values, we're gonna call them, the first one CW. We're gonna put their values CW. The second one U, and the third one we're gonna call it CI. And we're gonna place it as the following. Move this here and gonna connect this. And right here. Okay, so we got that connection. Now, um, so now we're gonna go into the library, into functions. And we're gonna insert 4 different functions, the MATLAB functions. In this case, it's gonna be this one. So I'm gonna need 4. And it's gonna be, so these functions are giving you the instructions. I'm just gonna go ahead and copy. So the function can be right here, but sorry, I forgot that there's another way to do it easier. And this one is called just function, or abbreviation FCN, and it would be the transfer function. Sorry, as mentioned, we have the MATLAB function. There's no easier way, so we're just gonna open this, and it's gonna create us a function. These functions are given in the instructions, so I'm just gonna go and copy. Right here, you can see I have the equation 1, 2, 3, and 4. So the first one for me is gonna be the 4th, and I'm just gonna go into the system and copy, and I'm gonna close it. I'm gonna go to the next one, and the same thing. I'm gonna copy the second one into it. This is very important that we name it just in case we lose it. So I'm just gonna go ahead here and keep the name. I'm gonna go to the third one. Um, copy and paste. And then copy and paste the name, because you don't want to be guessing which one is which. Number 4. These equations are given in the instructions, so please go ahead and check them. If not, you can screenshot it. Now that we have that, we're just gonna start putting the outputs. Sorry, the multiplexer. The multiplexer are, we're gonna have one of two inputs. This one are um, very different. So we're just gonna get one, paste it, copy and paste it. So what did we do? We exit. Sorry. Um, copy and paste. Copy and paste. So we're gonna go inside this one. We're gonna make it 3 to 1. Apply. The second one is gonna be 4 to 1. The third one will be, we're gonna keep it as 2, and then the last one is gonna be six different ports. Apply. This one we're gonna adjust it just to uh, visual representation. So this is where it's gonna get messy, but that's why it's important to have the different names. Okay, we're gonna go with the first one. Oh, we need the outputs. The output are gonna be outputs. Outputs. This and copy and paste. We're gonna need 4 different outputs. So this is very important. We're gonna have different outputs for different. So on the top, we're gonna have number 4. On this afterwards, we're gonna have number 2. Number 1 is gonna be the third. And number 3 is gonna be the last one. Okay, so we're gonna name it as following: percentage reg, other regulation, reg. The second one is gonna be DS. The third one will be IS. And the last one will be N. Let's see. Okay, so for the top one, we're gonna get the signal from this input. The second one for this input. And then the third one is gonna come out of equation number 2. So I'm gonna go ahead and forward this for time taking. You can screenshot it at the end and you will see it. So as we can see, we have already set up the the diagram. Once again, we're gonna adjust it. We have the outputs. Um, Everything we try to make it as symmetrical as possible, just for easy understanding. But as we can see, we have it here. So now we're gonna exit. And now we're gonna start connecting. You can see right here, the functions should be recorded. Once again. And we're gonna go out here and start doing our final setup. So it's each system, as we can see right here, it has different setups, and even within them, it has a different setup. So we're just gonna navigate, but we're gonna use these. The input we're gonna put it as PP, and then CL we're gonna put it over here, and then this buzzer is gonna be 4 inputs connected to the output. Once again, we're gonna make this one. So making the connection for multiplexer, and we can make it be. Then the output. We have it here. Now we're just gonna change the, once we're done with the setup, this is just for aesthetics purposes. We're gonna change the time to 100, and then we're gonna run it. If the simulation is successful, we shouldn't have any problem. So as you can see right here, we have a problem, and it goes back to, give me a moment. Um, as we can see right here, I have an issue. Um, if we want to track it down, we're gonna go see back here. And my biggest issue is that I didn't put parentheses, so I'm gonna fix that for all of them. And for time's sake, I'm just gonna not show you guys at the moment. So you guys will see once you. So as we can see, I went through the equations and fixed them. Now there are parentheses, and we go to Simulink. We run, it produces an output. This output, as you can see, is right here in the workspace. We can see it, and then we have different outputs. Is out R and totes. This will provide us different values, and this one will provide us another output. So we're gonna be working with these variables. At the same time, uh, the professor provides us with the following code. We're gonna input these values. Please copy and and do it on your computer. We're gonna run it. Then once we have all these, we're gonna have this plot as well, and then we're gonna run it. And this is the output. As we can see, we have three different graphs, and we can even adjust it if you guys want to see. It's very important to notice the name of the variable. In this case, I use my name and output. You see right here is out R. So we're gonna need to go and change that to out, 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 out R. This is a really needy part because we need to make sure these values are accurate. Since it's so what we're doing here is to call the simulation output based on out, the is our output, and then once inside here we have these two. We have the out R and the out. So in this case, we only calling our out R. So we run it, and it provides us the different graph. For its simplicity of viewing, we're just gonna eliminate this, and we're just gonna put it in subplots. Um, and we have it right here. Once again, one of the advice, do it on light script. It's easier for visualizing, and just make sure you have the different outputs. And like you can see, we can go inside here and just navigate um, in the different outputs. So it's very important to notice that these outputs relate to these outputs. And as we can see, we have IS, BS, and regulation. And if we go into the MATLAB in here, we go to out R, we're gonna have these ones. And these are the different values of I, B, N, and percentage. And that's it. That will conclude our lab. Thank you.